Hi, this is AD5NL, and I am going to show you briefly how you can tap the intermediate frequency on an ICOM 703, which has a lot of cool potential, and I'll run through some use cases as soon as I've finished describing it. The 703 is an older radio. It's about 20 years old. I've owned my 703 since 2006. I bought it used. It's the model that does not have 6 meters on it. It's been a fun QRP radio to take to the beach and the park and all of that, but now that I own a Yaesu FT857D, it's something that I feel that I can kind of hack without worrying about not having HF capability. So now note, this is going to void the warranty, so don't do it unless you're fairly comfortable with it. If you have a 703, good for you. If this is something where you're looking at getting one, I definitely recommend trying to get one as cheaply as possible before you do this. So just to give you a theoretical overview of what I did, let me go ahead and show you the ICOM 703 service manual. You can find the service manual online. I found it at radiomanual.info. And there's basically a section just about the receiver, which is section 3, that's got a nice block diagram here. So where we're going to be doing the tap is on the output of the crystal filter, which is labeled here as F1851. Note that the first IF is 64.455 megahertz. So when you tap this, you're going to have a radio that can receive in that range. We're going to be using an SDR dongle. It's one of the new elect dongles, which is basically a fancy version of the the R820Ts that you can get cheaply on Amazon. They are used for receiving DVB, which is not used in the United States. So you can get them on Amazon for like $12. Just to show you, I guess, a schematic of where we're going to do the tap. Let's see, it's on page 70, I believe. So 2 more pages to go. All right. Let's see here. There's the block diagram. Okay, so if you're looking at the schematic, which is on page 70, we're going to be hitting what is pin 2 here. Actually, I'm mistaken. It's actually pin 1 is what we're going to be hitting. It's actually the input to the IF filter, not the output. So the input here is the pin that you're going to be hitting. There is a little capacitor. It's a small surface mount component that's mounted right next to it. If you want to see an image of that, you can look at page it's basically page 2-2. There's a nice big photograph of the top of the radio. And again, what we're going to be hitting is actually the input. It's pin 1, and it is the pin here that is to the top and to the left. Now the component here is this kind of brownish, brassy-colored rectangle. It's got a label on it that says FL348, and it's towards the back of the radio and towards the center if you're looking at it from the top, with the front of the radio being down. So again, it's this first IF filter, and the pin we're going to be hitting is the one that is closest to the data port and the power connectors. So to show you the actual setup here, here's my radio, and this is the coax that's coming off the tap. Let's go ahead and open up the top. You're going to have a lot of screws here that you're going to want to deal with very carefully. So you can see internally what I did. I've got a little piece of 22 gauge wire that's actually making the tap, and then the 22 gauge wire connects to the coax. The shield of the coax I attach to a ground screw. Now ideally you'd probably run coax the whole way, and you could connect the shield of the coax to that little surface mount capacitor I told you about, because that is one side of that goes to ground. But I think just for simplicity purposes and because my soldering skills aren't so great, I went ahead and ran that. So that's how I put it together. The coax is from the cheap little antenna that comes with the USB dongle. Basically, I just cut the mag mount base off and used the coax from that to run here to the little dongle, which you can see here. Plugs into a USB. The new they're a little nicer. They've been working on some features that are useful for experimenters and building them into their dongles. So they're going to run you about $20-25. But if you wanted to go super cheap, you could get something that's basically just as nice for about $10 or $12 on Amazon. So once you got that set up, you're going to want to use some software like GQRX or SDR Sharp if you're running Windows to actually decode the output of that dongle that is receiving the IF here from the radio. So let me show you how to do that. So because I'm using Ubuntu 14, I'm going to be using GQRX. Let's take a look at how you're going to configure and use that with the IF tap. So let's open GQRX. Note here that I've got the input rate set to 1800 and the bandwidth set to 0 as the default. I would set the input rate. It's not going to work with 3.2 million, but it should work reasonably well with 2.8. And go ahead and set the bandwidth to 2 megahertz. That'll allow us to see 1 megahertz on either side of the center frequency. Let's go ahead and open that up. Now when you start, you're going to want to make sure that your receiver frequency is set to the IF frequency, so 64.455 megahertz. You're going to want to make sure that your LNB is set to 0, at least initially, although we're going to change that. You're going to want to make sure your LNA gain is reasonable. I would keep it on the low end, and don't use hardware AGC because it'll overdrive it. You're going to want to make sure that swap IQ is checked. Do any frequency correction that you need. In this case, it's about 50 parts per million, although you may want to check by dialing into WWV or something like that the first couple of times that you do this. Make sure your receiver offset is normal. I would go ahead and set it in AM usually by default, and I would go ahead and make sure your FFT zoom is 1 because you're going to want to see the whole thing when you first start. So let's go ahead and silence the signal. But you can see a lot going on here. You've got our center is 7 megahertz. And why is that? Well, because the radio itself is tuned to 7 megahertz. So what we're seeing is going to be centered on 7 megahertz. You've got a Panadapter view. These spikes over here are broadcast signals from the 49 meter band. Over here you've got some other broadcast signals. You've got the 40 meter ham band in here, and you can actually see, if you look carefully, some traces of CW signals here in the CW part of the 40 meter band. These spikes here just off the center. There's also some utility signals in here that might be worth exploring a little bit more. Just to dial in on a strong signal over here. Let's see what we're listening to. Sounds like music, possibly a Spanish station. or maybe Chinese, I'm not sure. But in any case, let's go ahead and go back to our center frequency. And then I'm going to show you how to get the correct frequency up here, at least in terms of what you're listening to. So you're going to want to apply an appropriate offset here. And because the radio is set to 7 megahertz, the appropriate offset here would be negative 57.455 megahertz. That puts our center here at 7. So when we go back over here and listen to these strong signals, we now know that we're actually listening to something that's at about 5960. Now I would recommend not touching this because that's going to start screwing you up. If you want to adjust your frequency, I'd do it over here with receiver options. Or just click on the signal in the waterfall or the Panadapter. So there's that. Now, of course, you could also zoom the FFT to zoom on a particular subband. Let's see. So let's slide over here. And I'm just kind of clicking and dragging. Let's look at one of these CW signals here. Obviously, in order to listen to CW, you're going to want to adjust your mode to CW. And then you're going to want to hit this as clearly as possible. Now, one of the advantages of doing an IF tap is you can do IF DSP. So we can cut out some of the noise by using a narrow filter. Now, if you overdrive this a little too much, the filter will start to ring just like a physical filter would. Now, note, again, this approach works pretty well when you're above about 3.5 megahertz. On the 703, if you go below that, you'll start getting a lot of images, a lot of birdies. So 40 meters, 20 meters, this should work fairly well. 80 meters is where things start getting a little dodgy. So in addition to doing basic IF digital signal processing, you can do some other cool stuff as well that I wanted to briefly show you. So note, first of all, that because the preamp stage of the radio is before the IF stage, you can turn the preamp on and off, as well as turn on the attenuator. And I would do that before fiddling with the LNA gain on the dongle. I think you'll have better results that way. Next, also, because you can monitor the relative signal strength, you can also see the relative ambient noise. So if you were to adjust your tuner significantly, you'll see drops in the noise level. And of course, if you tune for maximum noise, which is the usual advice when you're doing your manual antenna tuner, you can use this display to help you dial in your tuner. Finally, if you get the volume settings right, notice that I'm going to be feeding the output of GQRX RTP multicast, and then I'm going to go ahead and open FL-Digi and pull that capture from RTP multicast. We can use FL-Digi to decode the CW transmission. So here looks like somebody's saying his QTH is in Idaho. So that's the summary of my project. If you've got an old ICOM 703 sitting around, give this a whirl. I think you'll like the results a lot better than the radio by itself, which just has, the audio frequency DSP. So